Assalamualaikum warahmatullahi wabarakatuh. My name is Diana Rafni Hasman and my registration number is M192180069. Okay, on this video I want to tell you about propositional calculus. There is a statement revealing that a proposition is what is expressed by a declarative sentence. When the sentence is used to make a statement, but in the book of John Lyons revealed the relationship between a sentence and proposition. First, different sentences of the same language may express the same proposition. Second, a sentence may express two or more propositions. Third, not all the declarative sentences in a language will express propositions. Propositions may be true or false. We will use T to stand for true and F for false. A logical statement conveys factual information. If the information is correct, then we say the statement is true. And if the information is incorrect, then we say the statement is false. Okay, the first is negation. The negation of a logical statement is a new logical statement which say the opposite of the original statement. We can use the words it is not the case that, but such construction are clumsy and sometimes unclear. Okay, for example, the sky is blue. The negation is, this statement is, it is not the case that the sky is blue. But if we say the sky is not blue, it is clear, more clear than we use it is the case that. The next example is South Korea's capital is Seoul. The negation is it is not the case that South Korea's capital is Seoul. But it's better when we say this South Korea's capital is not Seoul. Okay, a proposition is usually using P, key, or R letter. The negation of proposition is written with, for example, the negation of proposition P is written with this sign. Okay, the next is conjunction. In logical terminology, it is not the connective itself, but the operation of conjoining and the resultant complex proposition for which the term conjunction is employed. The symbols that we can use are P and key, and just like this, conjunction. So I will show you the truth table. Okay, based on the truth table, we can get some fact about conjunction, about disjunction, implication, and equivalence. According to the truth table, conjunction true only when both of P and Q are true. Next, disjunction are divided into two, inclusive and exclusive disjunction. The first is inclusive disjunction. The fact is false only when both P and Q are false. Next, exclusive disjunction. The fact is true only when exactly when one of P or Q is true. And equivalence, false. The fact is false only exactly when one P or Q is false. The implication based on the truth table, the fact is when the antecedent is true and the consequent is false, so the implication is false. But at all other case, the implication is true. Okay, for example, in conjunction, first statement, this statement is chickens have two legs. Okay, this is true statement. And then key statement, for example, dogs have 4 legs. So chickens have 2 legs and dogs have 4 legs. So the conjunction of these two statements is true. And then, for example, if P statement is false, for example, dogs have 2 legs and chickens have 4 legs. The key statement is false, so the conjunction of this statement is false. The next is disjunction. Disjunction are divided into 2. The first is inclusive disjunction and the second is exclusive disjunction. The first, inclusive disjunction. The former is symbolized P, V, Q. Just like this. We can say P or Q, for example. Okay, remember the fact of inclusive disjunction on the truth table is false only when both P or Q is false. So, for example, the statement P is true, 5 is a prime number, and the statement Q is true, 5 is a odd number. So 5 is a prime number or odd number. So this disjunction is true. But when the statement P or and Q are false, so the disjunction of that statement is false. For example, 5 is an even number, or 4 is a prime number. These two statements are false. So the disjunction, this is inclusive disjunction, is false. The next is exclusive disjunction. The former is symbolized P double V Q. P. Okay, just like this. So remember, based on the truth table, exclusive disjunction true only when one of P or Q is true. For example, P statement, cameras are visual tools, and Q statement, cameras are audio tools. So if we use exclusive disjunction, cameras are visual tools, true statement, or cameras are audio tools, false statement. So this disjunction is true. Okay, the next is implication. The connective is P implies Q. P implies Q, or usually we can say, if on the statement, if P, then Q. In the standard interpretation of the propositional calculus, they are used in the so-called material sense, in which there isn't necessarily any connection of meaning between the antecedent and the consequent. Okay, remember, according of the truth table implication, if the antecedent is true and the consequence is false, the implication is false. But at all other case, the implication is true. For example, this statement, if paper made of cotton, this statement is false. And the key statement, iron is a solid object, this statement is true. So when we implies, if paper made of cotton, then iron is a solid tools, this implication is true, but when the antecedent is true and the consequent is false, the implication is false. For example, if paper made of wood, then iron is a liquid object, so the implication is false. The last is equivalence or the implication. The connective is like this. The definition of material equivalence that has just been given illustrates 2 points. Remember, based on the truth table, equivalence false only exactly when one of P or Q is false. So then we can say if and only if in equivalence. For example, the first statement, P statement, is Eka is studious. This statement is true. And the Q statement, Eka didn't pass the national examination. This statement is false. So the equivalence of this statement is false. Okay, I think that's all. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.